Conversions in the metric system. First thing you need to know are what your prefixes are, what their common abbreviations are, what their meanings are, and what number of them there are in comparison to the base. From smallest to largest, the common prefixes are milli, centi, deci. Then you have your base measurement of gram, meter, or liter, deca, hecto, and kilo. Here are their common abbreviations. The meanings are, milli means 1,000th, centi means 100th, deci means 1/10th, the base, of course, is 1, deca means you have 10 of them, hecto, 100 of them, and kilo, 1,000 of them. Here is their relationship in numbers in terms of the base. The base, if we claim that there is one of the base. The relationship is 0.001, that's a milli, 1,000th, centi, 100th, deci, 1/10th, deca, 10 of them, hecto, 100 of them, kilo, 1,000 of them. We're going to use this information to do some basic metric conversions. To find out how many hectograms there are in 120 milligrams, the easiest way I know to do this is using the factor label, which is sometimes called the dimensional analysis method. So I'm going to take the given information of 120 milligrams. I'm going to put that over 1 so that it's a fraction. Now I need to get rid of milligrams and turn it into the base unit. So remember, we looked at this. Milligrams, here's milli. My base unit is grams, and then we're going to take those grams and turn them into hectograms. So milligrams need to be able to cross-cancel, so I put that label down below. I'm going to turn those milligrams into my base unit of grams, but I didn't really want grams, I wanted hectograms. So now I need to be able to cross-cancel that label of grams, and I'm going to turn the grams into the hectograms that I want. Now, here's where I need to think about the relationship between these things. Milli means 1,000th. That means it takes 1,000 milligrams to make 1 gram. Hecto means 100. That means it takes 100 grams to make 1 hectogram. Now my labels of milligrams cross-cancel, my labels of grams cross-cancel, and I'm left with that label of hectograms, which is what I was trying to get to. Now I need to multiply straight across. 120 multiplied by 1 multiplied by another 1 is simply 120. 1 multiplied by 1,000 multiplied by 100, well, the easy way, of course, is 1 times 1 times 1 is 1, and I need 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So apparently that's 100,000. Well, now I want to simplify this problem. Anything that ends in 0 divides by 10. So right now I'm able to get rid of that. And I'm left with 12 in my numerator. And I now have a 1 with 1, 2, 3, 4 zeros. 1 with 1, 2, 3, 4 zeros. Or 12 over 10,000. Now in your science classes, your teachers are not going to like fractional form. So here's what we want to think about. There's an implied or invisible decimal point right there behind the 12, to the right of it. These zeros give me an idea of placeholders. Now let's start with a simple one, just to make sure that our brains understand what we're doing. If I have the fraction 1/10, that's a common fraction that hopefully everyone is aware of, is written as 0.1. See how there's 1 0 here? The implied decimal point had been, again, just to the right of the digit 1. Because there's 1 0, that meant I need to move that decimal point one place to the left to turn it into a decimal, and that's why it is the fraction 0.1. Let's try that again with another basic fraction. 1 over 100. This is again a common fraction that hopefully we're all aware of as being 0.01, because this is like saying I have 1 penny out of $1. This is how we would write 1 cent, 1 penny out of $1. Again, there's an invisible decimal point right here behind the 1, but this time in the number 100 there are 2 zeros. That means I want to take this decimal point and shift it 2 places to the left to turn the answer into a decimal, which means I had to write in a 0 as a placeholder, and that's how it became 0.01. We're going to apply that same idea here to the 12 over 10,000. There are 1, 2, 3, 4 zeros here in the number 10,000. That means I need to take the decimal point and move it 1, 2, 3, 4 places to the left. That means I need to fill in 2 zeros for placeholders. So as a decimal equivalent, this is the value 0.0012, or 12 out of 10,000. That is how you do conversions with metrics. Let's do another metric conversion. This time we want to take 150,000 milligrams and we want to find out how many decagrams there are. Remember, capital D for decagrams or DK for decagrams is another way to see it. I'm going to take my given information, the 150,000 milligrams. I put that on top. Draw the line across. And remember, we need to first take the milligrams and turn it back into its base unit. So cross-cancel the milligrams by putting milligrams down in the denominator. Milligrams, the base unit is, of course, just regular old grams. And now I'm going to take those grams and turn them into the decagrams that I wanted. Again, I want to be able to cross-cancel, so I'm going to bring my grams down below and put my label of decagrams up above. Now I need to fill in the information as far as their equivalencies. Milli means thousandth. That means it takes 1,000 milligrams to equal 1 gram. 1,000 milligrams are equivalent to 1 gram. Now I need to look at the relationship between decagrams and grams. Deca means 10. That means it takes 10 grams to make a single decagram. I'm now ready to do my multiplication straight across. 150,000 multiplied by 1 multiplied by another 1 is simply going to be 150,000. 1,000 multiplied by 10, remember the nice shortcut is 1 multiplied by 1 is of course 1, and there are now 1, 2, 3, 4 zeros. I need 1, 2, 3, 4 zeros. So apparently 1,000 times 10 is 10,000. Now we're going to do some simplifying. Remember that things that end in 0 divide by 10. So these both divide by 10 once. Look, they both divide by 10 again. They both divide by 10 yet again. And they both divide by 10 one more time. I'm now left with the information of having 15 in the numerator and 1 in the denominator, which of course means I want to ask myself, how many times can 1 go into 15? It goes into 15, exactly 15 times, so apparently 150,000 milligrams is the same as 15 decagrams. Alright, let's do another conversion. Let's get away from grams for a while and work with meters. So I want to take 0.23 centimeters, properly read as 23 hundredths centimeters, and find out how many kilometers that is. Well, I'm going to take my given information, that 0.23 centimeters, don't forget your decimal point, set up my factor label, also known as my dimensional analysis problem. Make sure I put the 1 in the denominator so that this looks like a fraction. Now remember, with metrics, the easiest way is to simply take the given prefix, centimeters, and turn it into its base unit. The base unit of centimeters is just regular meters. But I didn't want the regular meters, I wanted to go to kilometers. So now I'm going to take that label of meters, and remember it needs to come down into the denominator so that it will cross cancel, and I can turn the meters into kilometers. Now what I need to do is find out what the equivalencies are between these things. Centi means hundredth. That means it takes 100 centimeters to make 1 meter. Now I need to look at the kilometers to meters information. Kilo means thousand. That means it takes 1,000 meters to make 1 kilometer. Now that I have all my information, I'm ready to multiply straight across. Anything times 1 is itself, so that 23 hundredths, or 0.23, will remain the same in my numerator. 1 times anything is itself, but I've got all those zeros, remember. So 1 times 1 times 1 gives me a leading 1, but there are 1, 2, 3, 4, 5 zeros in the denominator. I need 1, 2, 3, 4, 5 zeros in the denominator. Now in my previous examples, I showed you how you would cross-cancel the zeros from the top and the bottom because you would be able to divide by common values of 10. This problem doesn't have this situation. What it does have is the example I showed you in the first problem, where we need to count how many zeros there are in the denominator so that I know how to move this decimal point. So let's come on down here and look again. I've got the 0.23 over 100,000. We said that we have 5 zeros. Remember, that means I want to take this decimal point and move it 1, 2, 3, 4, 5 places to the left. That means on this particular problem I need to actually fill in all 5 places with zeros for the placeholders. So as a decimal equivalent, there's my decimal point, 1, 2, 3, 4, 5 zeros, the 2 and the 3 that I started with. And that is how many kilometers are equivalent to 0.23 centimeters. And we're done.